developed by the Qt company. Yeah, so as we are very time bounded, so I would just go, first of all, let me introduce myself. My name is Filip Wasil. I'm a C++ programmer. I work for Siili auto company on next generation instrument clusters in automotive industry. In my private time, I do some OpenGL projects, and also recently I had a chance to work on a small Vulkan rendering engine as a proof of concept for the Siili auto. So first of all, let's start with what Vulkan is exactly. And well, it's a graphics API introduced in 2016 by the Kronos group. It was initially based on the AMD Mantle specification. And it's, making long story short, is an alternative for OpenGL, but much more explicit with its functionalities, giving much deeper access to the GPU functionalities. And also is considered a modern API. It was designed with multi-threading scenarios in mind. It was designed to handle, to utilize multiple physical GPUs. It's supposed to reduce driver overhead and reduce the CPU load. And well, in automotive industry, it's not always the case to have more and more FPS, because actually stable 60 FPS is enough for us. What we care more are the safety aspects of the API. We want to be able to speed up the startup time. We want to be able to profile the application, to debug the application, to get as much information as possible. And in case of Vulkan, Vulkan gives us a couple of cool features. For example, explicit memory management. It gives some additional extensions which can be used for optimizations to optimize the application. We are able to have, yeah, as I said, we have more control over memory and also more control over the memory transfers operations and better validation mechanisms. And as I already said, we are able to additionally reduce the CPU load. And the way Vulkan is able to reduce the CPU load is it makes it possible for you to create stuff in advance. So probably you are familiar with the OpenGL workflow when in your rendering loop, you constantly call hundreds or even thousands of API calls. Vulkan makes it possible to batch, let's say, to bake these commands into single or into few so-called command buffers. Additionally, it's possible to create secondary command buffers, so the ones that you can attach to the primary command buffers, and you are also able to create render passes and sub-render passes. So we don't have much time here to go into the details of all of this stuff, but basically, it's possible to create stuff in advance. The way you don't have to recreate it each frame like you had to do in OpenGL case. And probably those of you who had an opportunity to read some code, especially to read some Vulkan code, you probably noticed that to draw a single triangle, you have to write more than 1,000, 2,000 lines of code. So quite much, but remember that the way you work with Vulkan is you try to create an abstraction and you expose the features that you are actually interested in. So later on, if you're already done with the boilerplate code, you just end up having your own abstraction with all the features that you need. So yeah, so this is not a big deal. I think that you at the beginning have to write a lot of code. And when we started talking about Vulkan, probably it's a good idea to start with the way Vulkan handle errors, because less errors is what makes software safer, right? So basically, as you remember from OpenGL, OpenGL gives you this GL get error function and GL check frame buffer status function. And these functions makes it possible to obtain our error code. But well, these are the error codes that were possible to get from the API. They are not much descriptive, and there's also a lot of the information about the error code actually doesn't give you a lot of information about the context of the function execution, and that doesn't give you information why exactly the way you call the function is wrong. So, well, you have this information, but it's not enough. Maybe it was enough when they introduced the OpenGL, but nowadays Vulkan or maybe Kronos group came up with a solution of so-called validation layers. Validation layers are possible to be turned off or turned on during application initialization. So the way you work with it, you just use the validation layers you're getting out of the box by using the Vulkan SDK. And anytime you do something wrong, so for example, you call a function with invalid parameters or you pass some null pointer somewhere, what you will get is you will get the information what exactly is wrong, why you shouldn't call the function in a way you called it in current context, and it will also give you information about the exact line in the Vulkan specification when you will find more about the exact case that you are facing. So quite amazing, right? And also, if it's still not enough for you, you can create your own validation layers. As I said, validation layers you're getting out of the box with Vulkan SDK are open source. So you can always have some information there, how to write your own ones. And especially for cases where you have a project that has some specific requirements and you don't want to check for these requirements in the code. So you don't want to implement additional functionalities to constantly check for this, to constantly validate your code. You are also able to inject your own validation layers and, for example, run them for the debug builds and turn them off for the release builds, or any other way you would like to work with it. These are a couple of examples, including the default validation layer, so LunarG standard validation. It recently changed its name, I believe, for Kronos, VK layer Kronos something. But yeah, the point here is that you have all of them available, and for specific hardware platforms, you will have even more of them available to use. So yeah, if you want to know more about them, here are a couple of links. And now let's move to the other thing that differs OpenGL from Vulkan, which is the memory model. So probably you remember from OpenGL that in OpenGL, when you want to upload buffer data to the GPU, all you can do is actually pass a driver hint, which will be then processed or not by the driver. But of course, it depends on the driver implementation. So it may be that you will pass this additional flag, and what actually the driver will do, it will just ignore it. And in Vulkan, they make this memory model a bit more complex. So they introduced so-called memory heaps. And if you look at Vulkan memory model, you will notice that there are two types of memory. There's a host memory and device memory. The host memory is memory accessible from the CPU and the GPU. So for example, if you want to map a uniform buffer for the purpose of uploading data to your shaders, you will use a host buffer, host side buffer. And on the other hand, if you want, for example, to upload a texture, you will want to put the texture in a so-called device memory. So in the memory that will be accessible faster from the CPU. So in Vulkan, what you can do is you are not only able to tell where the memory is gonna end up in the end, but you are also able to introduce memory usage flags, and you are also able to define the process how the data is going to land in the memory that you want it to be. The basic pattern when uploading data for a Vulkan buffer or Vulkan image is that you create an object with some flags. You ask Vulkan for memory requirements for this object. You ask a Vulkan instance technically, but yeah, we will not go into details. Then you ask for a memory that meets these requirements. And after that, you allocate the memory with the size you want, and you bind the object you created in the first step with this memory. So this is a common pattern for images and for buffers. Of course, just like in case of OpenGL, you want to keep the number of memory chunks as low as possible, putting multiple meshes into single buffers. For uniform buffers, you are able to, as I already said, map the memory and unmap it when you need it. And you are also able to upload data to shaders using the push constants command to not allocate the memory explicitly. And as I already said, you are able not only to tell where you want the data to be, but you are also able to specifically say how the memory is going to get there. So, for example, to upload a texture in Vulkan, what you want to do is you want to create a host site accessible buffer where you're going to, in the first step, copy the data. So you create a buffer, map the buffer, fill buffer with data, and unmap it. And in the next step, you will want to copy this data from the staging buffer to the device local buffer. And the way you do that in Vulkan is you create a memory barrier to ensure that the data is already in the staging buffer. Next, you trigger a copy operation from the host side memory to device side memory. Then you set a memory barrier to guarantee that the memory in the device, that the device memory was already written. And after you are done with all this stuff, you gather it all to the single command buffer and submit this command buffer for execution. So very, very explicit way of handling the memory operations. And if you want to maybe not validate, but if you want to track the memory usage in runtime, you also have additional so-called memory budgets extensions to use. So the way memory budgets makes it possible to track the memory usage is that for each application that uses Vulkan API, you are able to track two things. So basically, you are able to track how much memory is available for you and how much memory your application is using. And this is extremely useful in the cases when there are multiple applications running on the same operating system, and some of them are using a lot of memory. So if you have two applications and one of them the first one is using a lot of memory, the second one will ask for a memory budget. It will see that the memory budget is low, and it will adjust its behavior or any kind of memory allocation policy to just to be aware that the other application is using a lot of memory. Yeah, and also when we're talking about the extensions, memory budget are of course not the only one that it's possible to be used with Vulkan. There's also additional one, pipeline statistics. The pipeline statistics can tell you exactly how much vertex geometry and any other shaders are being invoked between two commands in the command buffer. And also additionally, it can give you the number of primitives that were processed and the number of primitives that passed the clipping stage. So in the end, if you are using both of these extensions, you will end up having some numbers, as you see in the example. So in this case, we have two memory heaps. One of them has 4 gigabytes, other one has 12 gigabytes of memory. As you see here, there's a usage printed out and some numbers according to how many shaders were executed. And in case if it's still not enough for you when profiling the application, you are still able to debug application with RenderDoc. Essentially, RenderDoc is just a tool, it's a great tool to inspect a frame after it's being rendered. It works with multiple APIs underneath, so with OpenGL, Vulkan, DirectX, and so on. And the way you use RenderDoc is you catch a frame and then you are able to tell every detail of how the frame was rendered. So all the draw calls, the API, you are able to inspect the API. You are able to inspect any meshes, any buffers, any intermediate textures, for example, for deferred renderers scenarios. And also the timeline when you can also, for Vulkan cases, you will see the memory barriers. Main information here is that you don't lose anything when moving to Vulkan from OpenGL because all the stuff is available just like in case of OpenGL when we talk about RenderDoc. And here is a short example here. Yeah, you create a render pass, you call a clear operation, draw a cube map, draw some elements, and the render pass and submit the command buffer. And also you are able to use the RenderDoc tool for any kind of statistics regarding your rendering pipeline. If you want to know more, here are a couple of links. Now, as I already said, Qt introduced its own abstraction over graphics API, and this abstraction is called RHI. And let me speak a bit about, let me tell you a bit about this API. First of all, what RHI is and what RHI is not. Well, RHI is not a Vulkan wrapper. RHI is supposed to be an abstraction over general graphics APIs. So you will find it possible to use Metal, DirectX underneath, Vulkan, obviously, and OpenGL. As I already said, usually having more FPS is not the only motivation. It's obviously nice to have, but it's not the only motivation for us. For example, in future, we might expect hardware platforms that will not have the OpenGL API available at all. So in these cases, it would be great to have this kind of API like RHI, because yeah, and it follows the idea of so-called Qt everywhere. So they wanted their software to run on every platform. Of course, you may gain performance, but this is not the main goal here. And here is an example of the usage of the RHI. Basically, if you look at naming may be familiar. If you're familiar with Vulkan, the naming might be similar, but the API is much simpler. And basically, after a few steps of initialization, later on, you will just end up having this few kinds of resources. So a clear abstraction over resources, RHI texture, sampler, buffer, graphics pipeline, and so on. And the way you will use these resources is you will just use the RHI main object and you will just call a new function. So new sampler, new texture, new buffer, and so on. To have it instantiated over the GPU side, you will call the build method. And after you are done with using the resource, you will just delete the pointer to the resource, and that's it. Also, I didn't talk about it, but in Vulkan, the synchronization aspect is the synchronization objects and basically the synchronization stuff are very important, and the API is very explicit in this field as well. But for RHI, they decided just enough for you to have an object that will collect all the stuff that has to be ready before actually starting the rendering. So basically, you have this RHI resource update batch object, which you will later on pass to the begin pass function in the rendering loop. So the way it works is just you are able to tell what data, what resources, what operations has to be ready before starting the actual drawing. So you are able to do that having the simple API, and you don't have to worry about any specifics for Vulkan. Yeah, and that will be it for the RHI. If you want to know more, I definitely advise you to visit the tests to the repository, git.io, and especially the tests on the RHI API. So there you will find the a lot of examples of usage of the API. Yeah, and well, to summarize the talk, if we are using a raw Vulkan application, we can benefit from the validation layers. You can benefit from extra control over memory, extra benchmarking possibilities, and profiling extensions. And if we are using framework with Vulkan backend, we might expect to have more stability on the driver side, as the driver will be much simpler than in OpenGL case. We might expect to have API working on platforms that do not have OpenGL backend at all. So in case we have such platform, Vulkan is available, great. And also we might gain some performance and reduce the GPU load, and especially we can reduce the CPU load. But as I said, it depends on the driver. When looking at the bad sides of using Vulkan, well, it's still considered a new API in the industry, and not all hardware vendors provide necessary drivers. Not all frameworks have the Vulkan backend available. Fortunately, Qt has. And some people find the API more complex than the OpenGL, but well, as I said, it's basically a matter of writing a good abstraction. And when writing this abstraction, you will expose only the stuff that you are interested in and what you want to control. So in the end, you will just end up having exactly what you want. Well, yeah, that's it. Thanks for your attention. And if you have any questions, it's time to ask now. Thank you.
Great, thank you, Philip. Yeah, just a reminder, you can use the Q&A button at the top of the interface for your questions. I think we have one question more of a comment. So we'll wait for a little bit for some questions that you might have.
Okay.
Are there any kind of more frequently asked questions or anything that comes up or anything that you'd like to cover while we wait, Philip? I think there's actually another comment just came through, but not a question yet.
Yes, exactly. Yeah, so as we don't have any questions yet, so just a reminder, if you want to know more about the RHI, really great place to start is the tests available on the Qt repository. There's a lot of examples there, and as we didn't have much time to cover all of the usages, then yeah, it's a great place to start.
Okay, I think there's a couple coming in now.
Yeah. So maybe a quick question about the tutorial I recommend for using the VulkanRHI. There is a guide called Sasha Williams. You can easily find it on GitHub. He has a lot of great materials and not only code, but a lot of explanations there. So it will be definitely the place that I would start. And the other question, is RHI part of Qt? Yes, it is. It's supposed to be a optional. It's a backend from Qt Quick 3D, and it's available, as I said, on the repository that is, and you can find it using the link I pasted. And it is a part of the Qt, yeah. Which API is? Okay, the question was about for the RHI, is the OpenGL or Vulkan more optimized? Well, the obvious answer here is that it depends on the driver. Everything depends on the driver. You might end up having an application using Vulkan API, which will have less FPS. But it depends on the driver, and it depends strongly on the scenario that you are using it for.
I think we have time for one more question.
Okay, so the question was about can I use the RHI with Qt widgets? And basically, yes. The answer is very simple. Yes, you can do that. Once again, you can look at the examples, the official examples of the actually not even examples, but the tests for the RHI in the official repository. It's a great place to start, and by having a look there, you will just know every detail of the API. Yeah.
I think we've got one more question and time for that. There's a few there.
Well, the question is, should we use the RHI or what will be the difference between in performance between Qt Quick 3D and the direct RHI? Basically, Qt Quick 3D will be much simpler to write, but probably you will get more performance with the RHI. But in the end, the Qt Quick 3D will have a backend, the RHI backend. So it's actually not a question which to use, because using the Qt Quick 3D, you will end up using the RHI anyway. So.
Okay, yeah, I think unfortunately that's all the time we have for today. But I'd like to thank Philip for your interesting presentation and everyone for joining. Like mentioned in the beginning, for those questions that we didn't have time to answer today, we'll follow up on those after the session. You can leave us feedback by sending us, filling the survey on the keep.io /thank you survey button. You can also join the next live session via the live event page, and also chat to our Keep Professional Services on the live chat on the event panel. But thank you so much again, and have a great day.